integrate that. Oh, I have to rewrite it like this. But how is it? Well, why was there 2 here? Why was there 3 here? Anybody know? You don't know. Could have been a 5 and it could have been a 7. Somebody's going to give you an integral like this. Somebody will say, hey, calculus 2 fell. Please integrate that for me. Mr. Allison knows he's not going to do a U substitution. He says, you know what? It would be nice if you do a turned up into something like this. Which would be a times the natural log of x minus 3 plus b times the natural log of x plus 5 if you wanted to integrate it. You just don't know what a and b are. How do you find a and b? Well, if they are the same, then they are the same. So if x is 5 here, then x is 5 here, and you see what you get. And if x is 10 here, then x is 10 here, you see what you get. Then you're going to ask your Math 99 friend or your college algebra friend to say, hey, you know, apparently I can rewrite this as this. Why? Because I know this is easy to integrate. What? Just rewrite it. Okay. You say, well, now if you can give me those numbers, I'm on my way. It will just be a times the natural log of x minus 3 plus b times the natural log of x plus 5. And give it to your math college algebra. Please tell me what a and b are. How do you do it? Well, you put a 5 here and put a 5 here. You'll see you get an equation for a and b. You put a 7 here and you put a 7 here. You get an equation for a and b. You got 2 equations for a and b. Your college algebra friend is jumping up and down. What do you call it? A substitution, elimination. What do you want? Right? That's how you find your a and b. Okay? Well, this is what is partial fractions. Partial fractions, when you have something like this, you want to rewrite it. Because you are, well, it turns out that I can write this as this plus this. It happens that a is what? 2 and b is 3. Now, how do I know that? Now you can go check. If you put other numbers here, they won't be the same. If you put other numbers, they won't be the same. So partial fractions is a way to find these numbers so that you can integrate it. Now, what I'm saying is, anybody know what this is? This is called what? Huh? What is it? Yeah, what do we call this? No. It is not an equation.
Proportion.
Huh?
Proportion.
No. Anybody know what this is? Starts with the letter I. Next letter D. Next letter E. Next letter N. Identity. Which is to say, this is the same as this. That is to say, you can hold your ear like this, or you can hold your ear like this. That is to say, this is not an equation. You can hold your ear like this, or you can hold your ear like this. It's called an identity. Not an equation. Why? Because if you say, this is the same as this, I just choose to write it differently depending on the context I'm in. Depending on the context I'm in, I may choose to write it like this. And depending on the context I'm in, yeah, sometimes people do this. They write like this, sometimes like this, they want to break it up. You have to know what they're doing, why they want to do it. Yeah, that's to say, if you put a 5 here and you put a 5 here, you'll get the same thing. You put a 10 here and you put a 10 here, you'll get the same thing. You put a negative 9 here and you put a negative 9 here, you'll get the same thing. They're the same. So these are the same. Meaning that if you put a 5 here and put a 5 here, you'll get the same thing. If you put a 10 here and 10 here, 4x that is, you'll get the same thing. If you put a 10 here and you put a 10 here, well then do it, you'll see you'll get an equation for A and B. And if you put a 12 here and put a 12 here, well do it to get an equation for A and B. If you have 2 equations for A and B, then you solve them by simultaneous equations or substitution or elimination, whatever. Let me show you. Let's do it here. Apparently, this is the same as this. So you can put some values of x that you want. Any values of x, they should be the same. Mr. Harris, give me a value of x you'd like to put here and a value, but please make sure x is not 1. And please make sure x is not -2. But give me another value of x that you'd like to put here and you'd like to put here. 0 is good. What do we get here? A over plus b over is equal to 1 over. And then you have your first equation for A and B. What do you do next? We'll put another value of x in there. Give me another value of x. 4! Okay, let's put 4 in there. So we have A over 3 plus b over 6 is equal to 21 over 18. Now your college algebra friend is jumping up and down. You give it to him or her, and they'll say, well, I'll tell you what A and B are. You can do elimination, you can do substitution, whatever you want. You're going to get A equals 2 and B equals 2. That is the hard way to do it. Okay, that is the hard way. I'm going to show you an easy way to do it. I'm going to show you an easy way to do it. Partial fractions. So we have a polynomial divided by a polynomial. But we are trying to integrate. Now the first thing is, if you want to do partial fractions, the degree of the numerator must be less than the degree of the denominator. So the degree of P must be strictly less than the degree of Q, otherwise you cannot do fractions. They call them improper, and then you know what improper is. It's not proper. But I assure you, this is not a restriction. Why? Because if the degree of the numerator is higher than the degree of the denominator, what do you do? Huh? Another word for factor. If the degree of the numerator is higher than the degree of the denominator, what do you do? Anybody know? Huh? Huh?
Integration.
Oh, we're doing fractions here. No integration, no fracking of the college algebra. When the degree of the numerator is higher than the degree of the denominator, you what? You factor. And if you took Dr. J's pre-calculus class, he told you what another word for factor is. Divide. Factoring is dividing. I'm sorry. Tell me anybody, if you want anybody disagrees with me when I tell them that factoring is dividing, and they disagree with me, I'll explain it to them. Factoring is dividing. Yes. 6 divided by 2 is 3, and 6 divided by 3 is 2. Factoring is dividing. Yes, so let me give you an example. So here is a, here. (5x² plus 28x plus 29 over x² plus 5x plus 6. So what is the degree of the numerator? So this is not a restriction. We divide out. So what is the degree of the numerator here?
2.
And the degree of the denominator?
2.
So, strictly I cannot do partial fractions. But I can divide. Your college algebra friends get excited when you say divide. You must know how to divide, I'm sorry. Yes, that's it. You must know how to do it. X squared into 5x squared.
5.
You multiply that. Well, what do you do? Multiply out, right? 5x squared plus 25x plus 30. And you? Subtract, what do you get?
3x.
3x plus
1. Or negative. So,
and what does that say? Who had pre-calculus with me?